Okay, we do have to move along. Jose is with Greenpeace Spain, and he's going to talk on the renewable revolution.
Thank you very much. And thank you for the organization of ASPO for inviting Greenpeace to talk at this conference. I was asked to present the study that Greenpeace Spain commissioned about a 100% renewable energy system for mainland Spain. So what I will talk about is the context of how was the project that Greenpeace is developing on the energy revolution. Then what's the goal and methodology of this study? Or the first one, the first outcome of this analysis, that was the Renewables 2050 report, and then the Renewables 100% report, where we will show what was the cost analysis, an example of a 100% renewable mix, or a couple of samples to meet the whole power demand, and the summary of the outcomes and conclusion. So the reason to undertake this energy revolution project that is not being done only in Spain, but specifically the way we dealt with it in Spain was trying to find out answers to several key questions that we have in front of us. The main one is how can we find a solution to the biggest threat that humanity is facing, that is climate change. Do we have a solution to that? Are we on time? We do not pretend to have to provide an answer by ourselves. We rely on the scientific community coordinated by the IPCC to provide the answers. And we know from the latest reports that, yeah, we still have time, but the time is very short. So it is still possible, but it is every day is more difficult if we don't react. But so we need clearly to act to find a solution to climate change, and then we know that the solution necessarily means that we have to revolutionize the energy system. But then the question is it possible, this change? Is it possible to shift clean for dirty energies? And we try to take this question to a specific and real place, real countries such as Spain. Then the question was how much of the energy consumed in Spain could come from renewable sources. And if we found out that we have enough energy sources, then the next question is, would power be available anytime and anywhere? So wherever and whenever we demand power, would it be available with renewable energy sources? Thus, what happens if the sun is not shining? What happens when the wind is not blowing? If we find solutions or answers to these questions, still need to answer how would this work? How could this operate? How many renewable plants would we need? How should they operated? What should be decided? And also, how much would it cost? Would a renewable-based system cost more? So in order to find answers to these questions, then we define this project. The goal was to quantify and evaluate technically the feasibility of scenario relying on renewable energies for the power generation system in mainland Spain. So the methodology was based on several steps. The first one was an analysis of the capacity and generation ceilings. That is to analyze how much power could we generate from renewable energies. And that was published under the Renewables 2050 report. Then the second stage was a cost analysis to show how would it cost, how would every energy source or every every kilowatt-hour that was obtained from renewable power, from different technologies and sources, how much would it cost if we take them to the stable at the end of the learning curve. So we focus on the 2050 as a focus of the study, so that we could compare all technologies in the same conditions. Then a temporal analysis, that is to answer how could we supply demand at every moment. So the problem of how to match demand curve with supply generation curve. And finally, a power generation system analysis, that is how to, well, several parts of this study, of this chapter, dealt with how to optimize the system, basically, in order to find an optimum economical and technical solution. So the first report was Renewables 2050. This was based as a power generation system feasibility technical analysis centered in Spain's mainland, looking for the maximum possible contribution from renewables, including all kinds of restrictions in terms of resource availability, environment, land uses, and the coupling, time coupling between demand, generation, and transport. In the horizon 2050, so that is far enough in time so that we don't need to discuss first when are we going to reach there, but the question is if it is possible to reach there, and then after we set that question, then we can discuss if we can get there earlier. Well, the outcomes are being published under the Energy Revolution series of reports, and the first one was this Renewables 2050 that I'm going to deal with first. So this one talks about the capacity and generation ceilings. The methodology of this part was to start with population and energy demand scenarios taken from official sources, so we did not develop or imagine our own scenarios. We took what official institutions have published. At most, we extrapolated towards 2050. Then the analysis took every renewable technology that is known and available today, taking to what could be their situation and performance in 2050. But the basic assumption was to consider only technical options that are already here now. Of course, that is extremely conservative because we all know that we will have plenty, or we can imagine that we will have plenty more new technological developments in 2050, but that would be well, very speculative. So we want it to be based only on what is already available. Then we incorporated all the environmental, social, and technological restrictions over the available geographic areas and kinds of land. So in order to do that, a geographic information system was used to define what was the land availability in every kind of land within Spain's mainland. And with all that, it was calculated the maximum output, the maximum contribution from each of those renewable technologies. The study produced capacity and generation ceilings. Well, just to show that the study considered every technology, so the outcome produced maps like this one. For example, this one is for the CFP technology, concentrated solar power, where we could show what was the share of, or how would be the spread of the ceiling for different regions within Spain, and also, in the right side, what would be that amount of power compared to the demand in every region or to the demand of the whole country. Well, if we're taking all those analysis together, because it was done technology by technology, the summary of the results are shown in this graph. In the left colored circles, you can see the size shows the amount of power that we could get as a ceiling from every renewable technology, as compared to the projected demand in 2050. And what initially was projected to be the expectation, the question was, what would be the share of the demand that could be covered by every technology? We found out that with several renewable technologies, already individually, each of them could provide several times the predicted demand. You can see the size of the circles to realize the relative size of the power. And on the right side, there is another comparison with not only with the power demand, but with the whole energy demand, the total energy demand, where you can see that solar energy would be the biggest resource, with more than 8 times the total energy demand in mainland Spain. So the conclusions of this first part were that, and this is the main one, that electricity generation potential with renewable sources would be as much as more than 56 times the Peninsula mainland electricity demand in 2050, and also even more than 10 times the total energy demand. Most abundant renewable resources are those linked with solar energy. Wind power potential is much bigger than current planning targets. In the case of biomass, the conclusion was that yes, it is abundant, but not as much as other renewable sources. So maximum efficiency is needed in order to make a best use of the available biomass. Anyway, there appears to be infinite options to make a 100% renewable electricity generation mix, and in fact, it would be even technically feasible to supply 100% of total energy demand with renewable sources according to these numbers. And also that resources are widely distributed throughout the Spanish Peninsula territory. However, this does not, or this is not enough to prove that we could supply all the demand. With these first numbers, we could only, but this is important enough, show that we have enough energy to do all that. The second part of the study, already published on the Renewables 100% report, was the cost analysis. That was to compare what would be the cost of every kilowatt-hour produced by every one of the considered technologies when they are taken to the end of their learning curve. So when they have, we allowed them, all of them, to grow to this asymptote of the learning curve. And in the graph, we show the different technologies in order of merit of their cost cents per kilowatt hour. The conclusion in 2050, where that is the horizon of the report, is that the cheapest one would be wind power on land. Then appear other technologies such as solar thermal, wave, offshore wind, geothermal, hydro, some biomass, etc. And in a higher scale, in higher cost, so this is a different scale with this, in this second graph, the most costlier renewable solutions, such as most of biomass or photovoltaics, big hydro, And at the end, or the highest cost, you can see in dark or gray color what would be the conventional solutions in comparative terms. So the most efficient conventional technology that is combined cycle and gas power and nuclear power. And you can see that most of renewable solutions in 2050, when taken to the end of the learning curve, become cheaper than the conventional technologies. Then the next part of the study was to analyze the renewable, the electricity system, to see how could we match demand and supply. So I will just show a couple of examples. This is one of the. There were more than 50 mixes that were developed in the study, but just to show one example, this one was a certain share of renewable energies. One with all of them combined can supply 100% of the demand, not only in bulk but also throughout time. And the table shows different characteristics of this mix. For example, how much land would it use, less than 3%, or how much would the total power would cost, 4.5 cents per kilowatt hour. You can see in this graph the comparison between the demand, that is throughout the year, there is the blue curve, and renewable generation that would match the demand, but we will have in yellow the surplus power that would be non-used or unused in many times. An example of how this power could be placed throughout the country. Another example, this is a different one, using an economic optimization, including demand-side management. Then the mix looks different, with different combination of technologies. And on the left you can see the installed capacity, and on the right the electricity that is produced. And in this, in order to produce this one, there was a new concept added, that was the non-supplied energy cost. That means that at the few times where we would find excessive, expensive cost of energy supply, we took the decision that it is more sensible to cut this expenditure to a certain level. In this example, we put a very high top, just as an example, that is 500 cents per kilowatt hour. But in order to show that with demand-side management, we can supply still all the demand, just doing a better combination of demand-side and supply-side options. Well, I would need much more time to explain this. But just to go to the main conclusions of the main outcomes of the study. One is that geographic dispersion provides more regular generation throughout time. That we have many solutions to resources that are in nature are fluctuating, such as solar or wind power, and solutions are from more installed capacity, or to regulate the system with renewable technologies such as biomass, geothermal, hydro, that we can manage. Or the best one, that would be hybridization between solar, thermal, and biomass. That would be, in fact, the best solution that increases security supply and cuts system cost. There are multifold renewable mixes able to meet the whole demand. There is not one single answer, there are many ones. Technology diversity is a value that provides, that means that there is less necessary capacity and more security supply. We found out that there is not a significant need for energy storage, in fact very low. No technology becomes dominant when we go to 100% renewable system at minimum life cycle cost. 100% renewable mixes are more economic than current ones. Demand-side management is the most economic and appropriate tool to cover the few deficits in power that may appear. Energy planning is necessary if we want to get to an economically optimal mix. power grid is not a block, but of course it should adapt to a renewable system. And finally, that energy system makes more sense to consider the energy system as a whole, integration of the energy system, in order to get big energy savings and to cut total costs. And finally, that renewables will have to regulate in order to become main elements in power generation system. So the final conclusion of the study is that it is feasible to raise a power generation system based 100% in renewable energies in order to cover electricity demand and also if we want to cover total energy demand. The total costs of the generated electricity are perfectly acceptable and very favorable with regards to business as usual. And there are enough tools to guarantee demand coverage. So I conclude with what Greenpeace recommends in order to get to this scenario or to make this scenario real. That is, of course, we have many policy recommendations, but the main one is to set targets, mandatory energy planning targets. In the case of Spain, we recommend, especially for electricity, a 50% target by 2020 and a 100% target of renewables by 2050, at least. And, of course, several targets in the other sectors. Also, efficiency targets and CO2 emission reduction targets, because that's the main problem that we have to solve. And I don't have more time, so thank you very much.
I'm afraid we're right out of time. If we have 2 quick questions while we're getting the next speaker set up, that would be good.
Yes, okay.
Go ahead.
Yeah, my question would be, so you show that this enormous demand of energy, like 10 times the demand in 2050, which I imagine to be a huge amount if you take normal predictions, is possible to cover with renewable energy, which I doubt very much. But let's say this can be done. Do you think it should be done? I'm just thinking of that there is some direct correlation between energy use and environmental destruction on other parts. Like we have seen presentations about what's happening to mining, and we have seen that mining is very much dependent on energy availability. So let's just imagine if we use 10 times the energy, or if we have 10 times the energy that we demand in 2050, what will we do to this planet? So my question to you is, if it can be done, should it be done?
Maybe you got something wrong. I didn't say that demand would be 10 times higher. What the study does is to take business as usual demand scenarios and to look if there are renewable solutions for those demand scenarios. Of course, it's not the most sensible option to leave demand to grow business as usual. That makes no sense. But that was not initially the goal of the study. The goal of the study was to see if even in those not desirable at all scenarios, if even in those scenarios, if it would be possible to provide demand renewables. Because if we started with the other ones that we believe that are more sensible and more likely, in fact, that demand would be lower and should be lower. But if we only showed that with a much lower demand we could provide renewable power, then those who defend the nonsense endless growth model would say that, yeah, we know that renewable power is only feasible if demand is so low and so on. So we wanted to show that renewable is a serious option and must be considered anyway. But of course, the study also shows that if we want to go to the lowest cost solution, the lowest cost solution is a combination of renewables and demand side management and efficiency.
Thank you very much. So can we have the last question and fairly quickly, please?
If I understood well, your proposal is only for the power sector, is for electricity. If that's true, electricity consumption in our country is only 20% of the final consumption. So in fact, what you are proposing is that we should accomplish the European Union goals of 2020-20. If not, if you are proposing this for the whole system, you should take account, I think, peak oil, which is not mentioned in the whole report, because in that case, we'll need to go as a partial solution towards electrification of the transport, and that means that you should increase electricity demand for a while. But I would like to listen your comments on that.
The initial goal of the study was to analyze power generation systems, so to look for renewable solutions to the power generation system. But the first part of the study, that was the evaluation of the availability of renewable resources with existing technologies, then we found out that the amount was and is much bigger than we initially expected. So we made two comparisons with the projected electricity demand and also with the total energy demand of the whole energy system. And if you compare with the total energy demand, still renewable energy is more than 10 times in the study. So we could, in theory, provide a solution for the whole energy system. However, the initial scope of the study was for the power sector, so the most of the the most detailed analysis is done on the how to develop or how to manage a power system for, let's say, for the electricity demand. But there also some of the mixes were developed to provide with the whole energy demand, with not so much detail. That's something that we would like to develop further. But of course, if you want to consider the whole energy demand, you need to consider much wider electrification options, because the size of the system becomes much bigger than if we only consider the electricity demand. But in fact, one of the outcomes of the study is that considering the power demand in an isolated way finally makes not much sense, because we found out, as you could see in one of the graphs that I show, that you have a lot of non-used power at many times if you want to provide 100% of the electricity demand. So that unused power would be much better used and managed if we consider the whole energy system, and that, well, many new considerations appear. So we have some of the mixes that provide an answer to that, but that was not initially the main scope of the study. But it is there, but not so much developed.
Thank you very much.